I'm Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I'm going to discuss about the topic review of vector algebra in the unit 1 electrostatic studied in the subject electromagnetic fields and by waves and by the students of second year in the 4th semester. Today I'm before going to the topic the vector algebra. First, we have to recall about the electric field and magnetic field and what are the interconnection between electric field and magnetic field. First, before that, we have to know about what is field. The field is nothing but it is an effect generated by the particular materials. Whereas if the electric field it is generated by using electrical charges where the positive and negative charges. Because of this positive and negative charges there will be a force on each other so that the electric field will be generated. And coming to magnetic field, it is nothing but it is generated with the help of magnets, which is moving electrical charges, and it will produce as the current. By using this, the magnetic field will be generated, and in the moving conductor coil which is carrying the current, which in turn called as electromagnetic field. And coming to the topic of discussion, for today I am going to discuss about the scalars, vectors, and what are the vector notation used for that, and vector operations, addition, subtraction operators, and what are the real-time applications of vector algebra. And coming to the vector algebra part, the vector algebra, it is a one of the main component in our electromagnetic field, and where represents its magnitude and direction. Where the scalar quantity, it represents only the magnitude, where the vector which is having magnitude as well as direction. For vector, we can tell the force, displacement and current. It is a real-time examples of our vector quantity. And with the help of this vector quantity, we can directly relate how the electric field and magnetic field is related with respect to the change in a space and time. And coming to vector and scalar quantity, we know that the scalar which represents magnitude, which is related to the example of mass, temperature, volume, time, which is related to our scalar quantity. Whereas in vector quantity, it is associated with magnitude and direction, so it can be related with help of electric field, magnetic field, electric field density, magnetic field density can be related with help of vector quantity. And coming to the vector notation, it is having a two point, which is starting point and ending point. The starting point and ending point which represents magnitude, and the starting point which represents down, which represents direction. And the arrow mark represents the directed line segment with the tail. The starting point under Ln represents the magnitude, and this vector which is denoted with the help of arrow mark which can be represented. The example of denoting the vector is that A vector, B vector, C vector. We can like that we can denote our vector. And coming to the vector operation, there is addition, subtraction, dot product and cross product. Dot product and cross product will be comes under multiplication of vectors. And coming to the vector additions, when we are adding two vectors, A vector and B vectors, we are adding the magnitude as well as directions of both vectors, and resulting in another vector which is C vector, where C vector which is equal to A vector plus B vector, and the vector of additions which is following the commutative properties, where A plus B vector which is equal to B vector plus A vector. And coming to the vector subtraction, we can easily subtract the two vectors by using the vector addition rules. A vector minus B vector, which can be represented as A vector plus minus of B vector, and negative which represents the direction where it is in opposite. And coming to the dot product, which is a dot product which represents A vector dot B vector, and it is defined with the help of cosine angle, where the A vector dot B vector which will be represented in magnitude of A vector, magnitude of B vector, and cos theta, where cos theta which is a cosine angle when it is resulting in 0 if they are perpendicular. And coming to the cross product, A vector cross B vector, and a magnitude of a vector cross dot b vector into sine theta. In a dot product, the cosine angle will be represented. In cross product, the sine theta will be represented. And coming to the real-time applications of electromagnetic field, it is used in industry, medical applications, and power engineering, and modern wireless 4G technology and modern 5G technology. The electromagnetic fields are widely used. And these are the summarized part of our discussion. Today we have discussed about the review of vector algebra. In that we have discussed about the electric field, magnetic field, and vector quantity and scalar quantity, and what are the notations of vector quantity and vector operations is discussed, and last we have discussed about the real-time applications. These are the references I had made for this presentation. Thank you.